Hello everyone, and welcome to lesson 2.7, which is a quick lesson on long division. I know it's been a while since some of you have done long division. We might have forgotten the steps, so I just wanted to very quickly go over the steps in some examples of how we do long division. Okay, so the first thing is, in our first example problem, we have 245 divided by 8. So to start solving that, we have to know and look at the number 8, right? That's the number we're dividing by. So we start by checking what can it go into, right? Can it go into 2? Well, no, right? It's too small. So we move over one place value and we say, well, can 8 go into 24? Yeah, 8 can go into 24 3 times. Now that we have that, we have to multiply these two numbers, which is 8 times 3, which happens to be 24. And then we have to subtract it off. So do a little subtraction problem. Well, 24 minus 24 is 0. I'm just going to write that little line there to show that it worked out evenly. But now we have this 5 on the end. I'm going to highlight it in green. We have this 5 that we haven't dealt with yet. Well, to handle that, all we're going to do is we're going to take that 5, we're going to drop it down, and so now I have a new number to compare. So, for example, whereas before we took a look at 8 going into 24, so now I want to ask myself, can 8 go into 5? No, it can't. What do we do? Right? What do we do? Well, 8 can't go into 5. So, what we can say is 8 goes into 5 0 times, right? And then do the same thing. 0 times 8 is 0. We subtract. 5 minus 0 is 5. Right? Since that doesn't work, we can say, hey, our answer is either 30 with a remainder of 5, or we can choose to, and I'm going to highlight this in blue, to make it a mixed number, right? So a mixed number would be 30 and 5/8, because as you finish, we end up getting, and I'm going to write this in green, we have our whole number, if I can spell. We have our whole number here. We have our numerator at the bottom. And then over here, what we were dividing by is our denominator. And I'm just going to abbreviate that. So we could call that 30 and 5/8. Now, that process that we use to solve is just going to be used over and over and over again. So the longer the problem, the more times we have to repeat it, right? We figure out how much time the number, or how many times the number on the outside can go into a part of the inside, write that answer, multiply it, subtract it, get a new thing to check, do it over again, subtract, get a new thing to check, subtract, and you just kind of keep following that process until we're done. So let's look at a couple larger problems to kind of understand this. So in example number 2, we are going to look at our number 14. That's what we are dividing by. So what we want to look at is how many times can a number go into 14? Well, can 14 go into 5? No. Can 14 go into 56? Yes, it can. 14 can go into 56 4 times. You can check that if you would like. But 14 times 4 is 56. So, again, we multiply 4 times 14 to get 56. We subtract. And maybe we just write it like that. Hey, it crosses out. All right, so now all we have to do is we drop down the 7. Can 14 go into 7? No, it can't. So 14 cannot go into 7, so we have to take care of that. I'm going to write this in green still. 14 cannot go into 7 anyways. So 0 times 14 is 0. We subtract that off to get the 7. And now we can bring down the 3. So now the question is how many times can 14 go into 73? It looks like 14 can go into 73 5 times. And we know that 14 times 5 is 70. So we subtract, get the 3. And now we have our answers, right? We could either say it's 405 with a remainder of 3, or you could call it 405 and 3/14. Either way is acceptable. But notice that we basically did the same pattern each time. Also notice that when we got to the 7, we didn't just straight drop the 3 down, right? We had to put the 0 in there as a placeholder because we're dealing with all of our levels of place value. So we dropped the 7 to get that 0, then we could drop the 3 after we had subtracted. So it's find how many times does it go in, multiply, subtract. Find how many times it goes in, multiply, subtract. Find how many times it goes in, multiply, subtract. And we just do that until we get to the very, very last number. All right, so our last example here is 14,212 divided by 101. So it's definitely a very odd set of numbers, but just because the numbers are weird, that doesn't mean we do anything different. So we look at 101. Can 101 go into 1? No. Can it go into 14? No. Can it go into 142? Yes, it can. So 101 can go into 142 one time. So 1 times 101 is 101, and we subtract. So 142 minus 101 is 41, and then we immediately drop the next place value down. So now we're asking ourselves, how many times can 101 go into 411? It looks like 101 can go into 411 4 times. 4 times 101 is 404. We subtract that. 411 minus 404 is 7. And now we drop the last place value all the way down, which is a 2. And then we ask ourselves, how many times can 101 go into 72? 101 cannot go into 72, so that's a 0. Multiply, subtract, and we're finished with the problem. So your answer could either be 140 with a remainder of 72, or it could be 140 and 72 over 101. But either answer is acceptable. You just have to be on the lookout for how long or which way does the problems want you to express your answer. Hopefully this has helped, and as always, if you have any questions, please let me know.